Watch Mr. Wizard. Now, Mr. Wizard's not his real name, but that's what all the kids in the neighborhood call him, because he shows them the magic and mystery of science in everyday living. And they find out how to keep healthy and strong and have a lot of fun out of life, too. Oh, Willy, one of the kids in the neighborhood, is coming in the door right now. So let's join him and watch Mr. Wizard.
Hi, Mr. Wizard.
Oh, hi, Willy.
What you doing?
You see that?
Mm-hmm. Hey, it looks like a cellophane or something
Yeah,
like
it
that.
does look like cellophane, doesn't it? But it's
Oh,
actually
yeah.
glass.
Say, how do you do it?
Well, you blow it.
Mm-hmm.
But you'll be able to do that before you leave today, I think.
Good.
Well, because today we're going to look at some of the amazing things that come out of the ground.
Okay.
Can you think of some of the things that come out of the ground?
Copper and
Yeah.
iron, gold, silver, lead.
Hey, have you got any copper?
I sure have.
Yeah?
A penny.
Oh, well, let's see it. Now, there's an example of copper, as you know it. Now, you could have thought of all kinds of other examples of copper, too.
Oh, yeah, there's a kettle.
Yeah, a kettle, and there's a copper wire, which we used a couple of weeks ago, remember, to run electricity through?
Oh, yeah.
But here's the way you recognize copper in everyday life.
Mm-hmm.
Now, have you ever seen what it looks like when it comes out of the ground?
No.
Well, here, come on over here, I'll show you.
Okay. Over there?
Yeah, see right here?
Oh.
See this piece?
Mm-hmm.
Here's the way you recognize copper, and there's the way it comes out of the ground.
You mean that piece of gray?
Yeah, that right there is copper.
Oh.
Now, the big problem, then, is how are they going to get that copper out of the ground and eventually get it so it looks like in this penny? Now, they have a real problem here because every time they heat up all the ore, the copper and all the ores run together.
Oh, well, what do they do?
So here's how they do it. They take this metal and they grind it up. Okay?
Grind it up.
So let's pretend that this is the waste material, this sand. This is the waste material when they grind it up. Now, we'll put some metal in with it. I'm not going to use copper. I'm going to use some aluminum powder.
Oh, aluminum powder.
That's right. Put it in. Now, you mix that up, will you?
Sure will.
You got it pretty good? Let me mix it up real good. Here, let me do
There, maybe you can do it better.
finishing touches on it. Now, see, the problem is how are we going to separate that metal from all the sand there? The same thing as the ore. Well, they do it by using oil.
Oil?
Mm-hmm.
Hey.
Here's what they do. First of all, they take the metal and they put it in water. That's what I'm going to do here. Now, see how it's all down at the bottom there? That's because the metal sinks down to the bottom because the water doesn't have a hold on it.
Oh.
Now, in fact, you can even take it and shake it up, and you will see that some of it floats, but not very much. Here, take it and shake it up.
Okay.
Put your hand over the cork, though. That's it. Okay, now set it down. And you see how it still floats around down there?
Mm-hmm.
Now, here's what they do then. After they mix the ground-up metal with water, they add a lot of oil. I'm going to add here ordinary cooking oil.
Oh, look at the surface tension.
You see how it makes bubbles like that? Okay, now we'll put it together again. You shake it up real good this time and watch what happens. Okay, now set her down. See what happened?
Hey,
See all those little
on
bubbles?
the top.
That's right. Here's all the sand down at the bottom,
Mhm.
and all the ore goes up to the top. That's because the ore is grabbed hold of by the oil that you put in it, and because the oil floats, it brings the metal up to the top. Now, how they do this in the actual mining operation, they put the metal, the ground-up ore with the metal in it, in a vat full of water.
Oh, I see.
Then they add the oil, and they bubble air up through it, and you get this sort of thing. Watch. See how the bubbles?
Oh.
Isn't that interesting?
Gee, bubbles in water.
And that's how they separate the copper from the raw ore. And then they take it and refine it and heat it up and add all kinds of things to it, and eventually they get this penny.
I'll be doggone. They stamp it out.
They stamp it out, that's right. Now, can you think of any other coins that have got copper in them?
Oh, a nickel.
Sure, a
Oh,
nickel.
about 2 weeks ago you told me.
Yeah, I told you that a nickel had copper in it, didn't I?
Mm-hmm.
You see all that white stuff? That's all that aluminum paint.
Mm.
How light it is, it gets all over your hand. But never mind, we'll go on. Here is a nickel, and this has copper and nickel and silver in it. And here's a penny. That has copper in it also.
Right.
Now, they look pretty hard, don't they? Here, try to bend the penny. You know, it's pretty hard. Okay, now I'm going to fix that penny up so I think you'll be able to bend it.
Well?
Yeah. In fact, you want that penny?
Well, I think I can spare.
Well, I'll give it back to you, but I'm afraid it won't be in the same shape as it was in before because, you see, we're going to dissolve these.
Yeah?
Yeah, come on over here. Let's dissolve a nickel and a penny.
Okay.
Here, you take these. Now, see this flask here?
Mm-hmm.
See what's in the bottom?
Looks like water.
Well, it's not water at all. In fact, put the penny and the nickel inside there and you'll see. Now, in order to make sure...
Hey, it's turning green, dark green,
I'm going to set
yellow,
this
red.
timer right here so we'll be able to time the reaction. See? You see what's happening in there? See how it's beginning to bubble?
Look at it.
What I had in the bottom there was not water, but nitric acid.
Nitric acid.
And nitric acid is very corrosive. Beginning to smell the fumes. See how the fumes are beginning to fill up the bottom of the flask? Well, nitric acid is a very strong acid. In fact, you can see it's dissolving the penny and the nickel. In fact, when you combine nitric acid with another acid called hydrochloric acid, what's the matter? Bothering you over there? Well, here, stand back over there so you can get the fumes. Have you ever heard of aqua regia?
Aqua regia.
Yeah,
No,
that's Latin, and it means royal water. And that's half of the ingredients of royal water, that nitric acid and hydrochloric acid. When you get them together, man, that really bother you?
Oh.
Well, here, let's move over here a little bit then. Okay,
Ah.
that better? Now, this aqua regia I was telling you about is called royal water because when you combine nitric acid and hydrochloric acid, another very corrosive acid, when you put the two together, they will actually dissolve gold and platinum, the only fluids that'll do that.
Oh.
Now, while we're waiting for that bell to ring over there, I wonder if you've ever actually taken a look at a map and found where the various minerals come from.
I haven't exactly.
Well, let's take a look at them. Gold, lead, and silver mines. Here's a little mine
Way
coming
out
up.
west, most
Come
of
out
them
from the
are
west, that's
gold,
right.
Copper and lead
Here's
mines.
silver and gold and some precious stones. You know, they come from over in that section.
Silver,
And
gold,
copper.
and copper. Oh, yeah.
And
California.
they also come from this section up
Oh,
here.
Nevada.
That's right, over there. And they have some real big mines up in that section over there.
Oh, Colorado.
And even some lead mines.
I'll be
So
darned.
here's all the section where we get all the metals that we use in the form of cooking utensils and all that kind of stuff. In fact, if you ever get a chance to go out to the west and you go by into the mines, be sure to go in because it's very, very interesting. They have big railroad cars that go out and pick up the mine. You can see big furnaces where they melt it, and you'll be able to see that process that we just talked about, that flotation. So be sure and go in and when you get a chance. Well, let's go back here and see how our nickel is doing. You see that reaction down there? In fact, these fumes here. Ah, there we go. Now let's stop the reaction right away by pouring the materials in the water to dilute it and stop it. Now let's get rid of this. This seems to bother you.
Thank goodness.
Now let's actually take out that nickel and the penny and see what they look like. They're so thin, they're real hard to get hold of. There you are.
Wow.
That's what's left of the nickel, and that's what's left of the penny.
Oh.
See how that acid really dissolved them? Remember you tried to bend the penny before? See if you can bend the penny now. See that? Isn't that amazing?
Doggone.
Here, I'll wipe them off for you, and you can take them home as souvenirs.
Why?
There's an old bent penny and dissolved
Old
nickel.
tin.
Mm-hmm.
Is that what's left of it?
That's what's left of it. Yeah.
Tin?
Now, you see, the reason I wanted to show you these things is because you very seldom find metals in the ground in the pure state. They're always mixed with various things. This is one of the reasons because metals will dissolve in certain things. And, in fact, one of the most important is because in the beginning they were all heated and fused together by the heat of the earth. And that's the same thing that caused mountains.
Oh.
Did you realize that? You know how mountain ranges form?
Not exactly.
Here. Let's take this old cloth that we just used to wipe the coins off and pretend this is the crust of the earth.
You mean
See?
the dirt and all
Yeah,
that?
that's
the
right.
Rock.
And this is the earth when it was in the beginning. Now, in the beginning, the Earth was a lot bigger than it is now and was very, very hot. So I'm going to blow the balloon up to represent the Earth in the beginning. Okay, there's the Earth in the beginning, a great big ball of very hot metals and rock and all kinds of things. Now you take that cloth that's all full of dirt and stuff, and you put that over the top. This represents the surface of the Earth.
Should I hold it?
Yeah, you hold it on the sides like that. Now you see, when the Earth began to cool off, it cooled off most on the outside, so it formed a kind of crust.
Yeah.
Then as it began to cool off more and more, it began to get smaller and smaller. So now watch what happens to the crust of the Earth when I let some of the air out of the balloon here and make it smaller. Watch now.
Hey, mountain.
See how it's beginning to form into bumps? See that?
Right there.
Sure.
Look at it. Oh.
Oh, I dropped it a little bit, but actually it was up like that. See, and this ridge right here it would be a mountain on the face of the Earth. As the Earth got smaller, the crust had to get smaller to fit in with it, and so they get bumps and ridges like that.
Well, there's the cowboy chasing the bandit.
On top of the mountain. Well, that actually happens out west, and that's how the Rockies were formed, or at least one of the reasons, a long, long time ago. Okay, look out, I'm going to make the Earth into nothing at all. Now, did you realize that I told you that the Earth was very hot in the beginning. Do you know it's still very hot in the middle?
No.
On the inside of the Earth, it's very, very hot. And when the hot stuff on the inside of the Earth comes spewing out, we have a volcano.
Oh.
Here, did you ever realize how a volcano works?
No, not exactly.
Here, hold this up there.
Read about it in school.
Well, here's how a volcano works. See, here's the side of a mountain. Here's the other side. And down the middle of a volcano, there's sort of a long tube. Now, it's a tube that's just an empty space in the middle of the mountain, and the bottom part of it is connected somehow and through devious ways with the hot inside of the Earth. Now, the inside of the Earth is hot rock, all melted and molded and kind of plastic, kind of like clay. Now, when this begins to when it gets very hot, it tries to expand and go up this opening here. But then when it gets up near here, it begins to cool, and so it sort of forms a cap on the top, so it can't get out any further. But there's still a lot of pressure here. Now, many of the volcanoes are found near the sea.
Oh, I didn't know that.
And this is one of the theories as to why a volcano erupts. Now, this is only a theory, remember, and some people don't even think it's true. But here's one of the theories, anyway. Underneath the surface of the sea, there's a crack in the bottom of the sea floor, and that lets water run down in here and mix with this hot material.
Oh,
you know what happens then? Turns to steam and expands and blows the top right out like this. See, and then we have an eruption.
Volcanic eruption.
Have you ever seen a volcano erupt?
I sure have.
Where?
On films and newsreel.
You know what Washington is famous for?
Oh, it's apples.
Right, and Idaho.
Potatoes.
And they grow an awful lot of things in Oregon, too. At one time, Washington and Oregon and parts of Idaho were covered with a layer of lava. And when the other materials are added to it and it's ground up by the wind and the rain and all that sort of thing, it becomes very good ground to grow things on. So it's not so useless as you think, lava, because that's where you get potatoes and apples.
Oh, say, Mr. Wizard.
Yeah?
We've been talking about all the minerals coming from mountains up here. Well, what about the plains?
Well, actually, you get a lot of very important minerals. In fact, the most important minerals to you come from the plains. In fact, iron and calcium and potassium and phosphorus, they all come from this section right here.
Well, gee, when we went on our vacation, I didn't see any calcium mines or phosphorus mines or anything like that.
Well, did you ever see anything like this?
Citrus ones? Oh,
Yeah.
sure.
Or if you ever go up into the eastern seaboard, they have a lot of truck farming. They grow things like
Apples.
that. Or if you've ever been up in Michigan, you know that they have a lot of strawberries.
Sure.
And Wisconsin is certainly well known for
dairy state.
dairy state.
Cows.
And Iowa for corn.
Mm-hmm.
And the whole western section
For wheat.
for wheat. That's right. Now maybe you can get some idea how you get those important minerals out of the ground without mining them.
From the foods we eat.
That's right. In fact, this whole section here of grazing and farmland, the ground is full of those important minerals. Now, they're especially important because they regulate your body processes, you see. Now, when they're in the ground, the plants grow in the ground and they absorb some of the minerals, and you finally get them by eating 3 well-balanced meals a day, see? Let's go through that breakfast pattern we talked about and see if you can tell me some of the important minerals that we get out of it. Now, fruit, cereal, milk, bread, and butter. What important minerals do you get out of those?
Calcium?
Calcium, that's
You
right.
mentioned that.
Calcium is very important for growing strong bones and teeth. And you get a lot of calcium from the milk and the cereal in the breakfast. Now, anything else?
Phosphorus.
Phosphorus. Phosphorus is very important also to help build strong bones and tissues. And you get a lot of phosphorus in that breakfast, too. Anything else?
Iron.
Iron. Iron is important to build good, rich blood. And cereals are just chock full of iron. Now, any more?
Afraid you got me.
Well, you could have said iodine. You could have said potassium. Sodium. And some more. Now, these are some of the important minerals that you have to get in order to regulate your body processes. You just get little tiny bits of them, but they're very important. And it's also important that you get them every day. You see, the body can't store up an adequate supply of minerals, so you've got to get them every day in the morning when you wake up.
So you start out each day with a good breakfast of fruit, cereal, milk, bread, and butter.
Right. And when you start out the day with a breakfast of fruit, cereal, milk, bread, and butter, or for variety, you can add eggs or breakfast meats.
Sure.
You'll not only get all these minerals, but you'll get from 1/4 to 1/3 of your entire day's food needs. And you'll get them in the morning when you need them most. And then, too, don't forget, the doctors have found from their studies at a big medical school about the boys and girls. Remember I told you about that? Well, they found that when you've had a good breakfast, that you'll be able to work a lot better, that you will be a lot sharper and keener.
Right.
And you'll have a lot more muscular steadiness, especially during the late morning hours.
Gee, it'd be quite foolish to miss breakfast.
That's right. That's because you realize this.
That it's smart to eat breakfast.
Right. Hey, by the way, how are you doing on the other rules of good health?
Oh, sure. Plenty of exercise, fresh air, sleep, and water.
Right.
Plus 3 well-balanced meals a day.
Mm-hmm. Now, remember that ankle you turned over a couple of weeks ago? How's that doing?
Oh, it's healing up all right.
You know why it's healing up? Because you got those minerals.
Oh, yeah.
Sure.
Right.
Well, now, when we finished talking about the Earth over there, we talked about lava and mountains and all that sort of thing. But you see, there's a lot of plains all around. Now, how did they get there?
Well, how did they?
Well, let's look at some of the things that made the mountains break down into plains. Come on over here. I think I got something that's real interesting. You know, during the day, when there are lots of rocks around, the sun heats up the rocks. So we're going to use this blowtorch here for the sun. And then at night, it cools down, so we're going to use the water to cool it down. And here's going to be our piece of rock. You hold that, and I'll light the blowtorch, and you hold that piece of glass in the flame of the blowtorch and heat it up. Okay, hold it a minute. Now, you see, during the day, the sun heats up the rock and makes it expand. So more heat and more heat go pouring on the rocks until they're expanded quite a bit. And then, as the sun goes down, they begin to cool off. So let that get nice and hot. Okay, now put it in the water.
Wow.
See what happened? See how it broke right off? Here, wait just a minute. I'll get that forceps of mine and we'll get that out of there. And take a look at what it looks like. See how it's broken up into little tiny pieces? In fact, there's a little crack right here. You see that little crack? That little crack right there is exactly the same sort of thing that happens to a rock. When the heat of the sun heats it up during the day, and then it cools off at night, the rock tries to contract, and some of it's still hot, and it breaks it up into little tiny pieces. So that's one of the methods that the mountains are broken down into form plains and all sorts of other things. Now, I've got a question for you, a real tricky one. I want you to see if you can answer it. Come on over here. I got some pictures. See these 3 pictures of valleys? This one, and that one. Now, one of those 3 valleys is a very young valley. One of them is a very old valley. And one of them is sort of a medium-aged valley. I want you to pick out which is the old one, which is the young one, and which is the medium.
This for the young.
That's the young one.
This for the real old one.
Yeah.
And this for the middle.
Nope. In fact, here's what the right answer is. This is the very old one. This is the very young one. And this is the middle one.
Well, I was right on one.
You were right on this one, but you got these two turned around. Now, doesn't it seem funny? This is real old, and this is real young. Now, so you'll understand why this was an old one and this was a young one. Come on over here. Let's make a river.
Okay.
Here. Would you take this piece of galvanized tin over there and put it out like that? Here, you put this under that end. There. You take this over there. Now I got to prop this up. This is going to be our riverbed right here. Okay. Now here, in that jar, you mix all these together. Some stones and gravel. Here's some sand and some dirt. You mix all those together. Okay, mix them all up. Okay, here, I'll get these out of the way. Oh, you can mix them up better than that. Okay, now bring them over here. And we'll put them right here at the top of the river.
That's the mouth of the river.
This is the beginning of the river. Now, see here, we've got a mixture of stones and gravel and sand and dirt. Now let's run a river through it and see what happens. Okay, watch. Watch what the water does.
Gee, well, the dirt's blowing and a little bit of that sand. The big stone's just laying there.
Well, they move just a little bit. Notice every once in a while? But the gravel is being moved out. So is the sand. And so is the dirt.
Oh, yeah, there's one of the stones.
Here's what happens when there's a flood.
There she goes.
Okay, now let's pick this up so we can empty it out of a little bit of water so you can see what actually happened. Yeah, that's a river that flows along. Now let's take a look at that actually happened. See, when the water was flowing pretty fast, it was able to carry away some of the heavy materials, but it left all the big rocks. Now this is kind of corresponds to a young valley. The reason why a valley is young is because it hasn't had much chance to be eroded by the various elements. So the young valley is the one that has a lot of sharp peaks that go up and down. See, that's the young valley over there is the one that has the sharp peak sticking up, and it hasn't had much chance to be worn down by water like this. Notice that the water deposited the heavy stuff over here. It didn't move very much. Then let's go down here and see what happened. You see, the next thing that's deposited is the gravel and sand. Now this would correspond to what would happen in a river that flows through a medium-aged valley.
So that was the medium.
That was the medium-aged valley. It was able to deposit some of the materials and filled up the valley floor, and also at the same time wore down some of the rocks because of the erosion. Now let's go down and look at the bottom. You see how here where the water slowed down? It piled up all the dirt. There's no sand here, no gravel, just dirt. This corresponds to a valley that's quite old, like the Valley of the Nile, which the picture was over there.
Oh, yeah.
You see, when the river begins to slow down, it sort of meanders around and deposits all kinds of dirt and builds up what is known as a delta. The delta, yeah. And then over here, you see how the water is all muddy? Remember, this was clear water when I started back there. It's now this deposit is here, and finally it sinks down, and it will form a layer. So that's the answer of what is the old, young, and the medium-aged valley. Now here's something else that I think is kind of curious. You ever seen this before?
Looks like some quartz.
That's right, that's what it is. Do you know what happens to quartz when it's ground up by the elements and weather? What?
Sand.
That's right, this sand right here is quartz sand. Wherever you find nice, clean, white sand, you know that at one time or other it looked like this. Now, do you know what happens then when they take sand and mix it with other ingredients and heat it up? Yeah, I'll show you.
Glass.
That's right. When they combine silicon sand with lime
there's soda ash.
and soda ash and mix it all together, then they get this kind of glass. Now let's heat it up. Have you ever heated up glass?
No.
Oh, you can have lots of fun heating up glass. So let's try it. Now, you have to have a pretty hot flame.
You're going to let me blow it up?
Well, we can certainly try it. Here, you want to try it right now? Okay, first of all, we have to be sure it's good and hot. Okay. I think this is going to get a little tricky, Willie. On account of it gets pretty thick. You better let me do it. I'll see if I can blow a snowstorm of glass. Well, I don't know whether it's hot enough or not, but I'll give it a try and see what happens. No, not hot enough. Well, I'll tell you what we'll do. It's about time for you to run along home. So let's do this next week. Would you like to do this next week when you come back?
Well, what are we going to do next week?
Well, next week, besides blowing that glass, which I'll do for you, we're going to talk about what makes iron ships float. Doesn't that seem amazing? And here's a trick you'll be able to do at home. You take a jar full of water like that, you take a...
NBC Television.